Cool. So, hey, my name is Matthias. I'm a software engineer, like a pretty ordinary software engineer. I also build companies, I build products, and I work a lot in business strategy. And I wanted to know, like, who are you? Like, I would like to know who is a software engineer in this room, or coder, or whatever. Nice, okay. Who is like a vibe coder, but not a coder? What are the other folks? Like, what are you doing? Or why are you coming for a talk about tech? Okay. Okay, so I have a few questions for you. Number one is this. Who can answer me that question? What is a primary key?
Normally in relational databases,
Yes.
it is to identify, some snippet or something.
Okay, go one more. What is an array? Sure. Oh, you were. So it's basically an order collection, right? And something has an ID in there, and you can ask it, like, at this index, I want to have this value. And who can answer this question? What is an agent? Yes.
A person on an AI that can help you with anything, actually.
With anything? Okay. So I have one definition here, because there's a lot of times when I talk to people about AI is they know how to use an agent, they know how to use something like ChatGPT or whatever. But if you really ask what are the fundamentals of an agent, then a lot of people are like, I don't know. If I would have a job interview today and I would ask someone one question, I would ask them, explain what an agent is to me. Draw it, make a diagram, whatever. That would be the number one question I ask. And that could end the interview. So this is one definition. An agent is a loop that keeps executing tasks until it's done, or until completion. How do you best learn how an agent works? It's if you build something yourself, right? If you want to understand something from first principles, the fundamentals of something, you just build it. And that's what we're doing today. So we're building an agent. But we're not doing it like 2 years ago. We're doing it like 2026. So let me throw the terminal over. Where's this thing? There. So I'll launch my coding agent. And let me get the URL.
Can you take a picture?
Yes. As much as you want. Okay. So some time ago, I wrote a small blog post about how to write a coding agent. In this case, it's in Ruby. So what I will do here is I will take that URL and throw it here into this coding agent. So I'm just talking to it, right? So, hey, I want to build a small coding agent, and while I'm giving a talk here at this meetup, please, do it. All right, here's the URL. Just do whatever is there. Here's the URL. Do whatever is there. Okay. We'll let that tick away. In the meanwhile, let's talk a bit more about what agents are. So, in this case, it's not just something in a loop. There's always something going into your agent. You know that as messages, right? You type something in, and you type a message, it goes to the agent. What actually happens is, it transforms that into something called tokens, sends it there, the LLM does something, comes back with more tokens. So, small diagram here. So we have a user and we have an LLM. So the user is sending tokens, right? Typing in, hey. The LLM answers with tokens and, hey, how are you? And sometimes, when you have an agent, they will do things. They want to do things, so they get like you give an agent a screwdriver, right? Or a saw, and they can do stuff with that. So that's what we call tools. So tools also get tokens. And what they return to you, to the LLM, is tokens. So it's over and over, you're handing around tokens between the different players here. And there's one thing a bit like different. What the user sends is what they call state. So the state is not just like a message, it's everything. The whole conversation you have with your agent gets sent to your LLM all the time. What that means, let's look into that a bit more detail. Oh, sorry, that was too fast. Yes, so the LLM that is used here, whatever it is, it's what we call an agentic LLM. Why is it agentic? So it's like, I explain it like a squirrel when you see Ice Age, right? It wants to have that nut. Who has seen Ice Age? Okay. So it wants to get that nut. Whatever it takes, it wants to get that nut. And an agentic LLM, whatever it takes, it wants to have a screwdriver and do something. If it doesn't have a screwdriver, it will try to find things to build a screwdriver. So it wants to do things. It wants to get the job done. There's a bit of like a, sorry for the theory about LLMs. There's a bit of a spectrum there in terms of LLMs. You got agentic LLMs, like the squirrel on cocaine with a shotgun. And you got the oracles, which are like mainly for thinking, right? And you got these guys here, you probably read all of them. This got released yesterday, pretty exciting stuff. And on the other end, you have stuff like Opus, you read about that, you read about Mythos probably, right? Anyone heard about Mythos? Okay. It's they say it's a pretty dangerous LLM that could basically build bombs. And you got another spectrum here. That's what I meant, like it's a low safety LLM, so it just doesn't question things. It won't get back to you and ask you, are you sure? These guys will get back to you and ask you if you're sure. Let's look what our agent did. Interesting. So it built something. Let's see what we got there. Yes, nice. So it created, in this case, a Ruby file. I could have told it, like, okay, take this blog post and just write it in Kotlin, or write it in Golang. That's the job. So here we are. We just created our own coding agent. And we can tell it, hey, maybe it breaks. Hey, nice. So what we created is in probably 250 lines of code, and it can actually verify that. Let's see, 290 this time. A coding agent. And this coding agent can do stuff. And let me scroll down a bit. So here we got some tools, right? So we got a tool to read files. We got a tool to list files. And we got a tool to, what do we need? Edit, right? Edit. To edit files. So now you have an agent that can do all of that. And you can, from now on, create code with that agent, right? Let me demonstrate that a bit. Okay. So, hey, I know that you can modify yourself. I want you to implement another tool that you can call bash commands. Do that now. Don't make any mistakes. Let's see what it does. You see, it lists files, it reads files, it edits files. It doesn't ask me anything. It just goes ahead and does its thing. So now if you think someone created OpenClaw out there, this is the first step to OpenClaw. From there, you could go ahead and just build your thing, right? And you're in control. So you're not dependent on whatever others give you. So what does it say? It runs a command, blah, blah, blah. Okay. Let's see if it did it. Hey, can you tell me which tools you can use? It can run bash. Okay. So initialize this as a Git repository and then commit it with a funny commit message. Boom. So to verify that, here we go. We got a coding agent that was building itself. How much time do we spend on that? A few minutes. What I don't want to teach here is how to build a coding agent, because a coding agent is not hard to build. But if you want to learn about how these things work, please build a coding agent yourself. Let an AI build the shell and start playing with that. You're playing with 290 lines of code. You can go in, you can read it, you can let it be written in your coding language that you understand. Because it will transform you from being a consumer of agents to being a creator, to being a producer, right? And it will teach you stuff you didn't know about LLMs before, about agents, about how they work. So if you don't want to go through all of that, I like to point people towards this one. It's called Pi. It's a really cool coding agent. It's free, and this guy is worth following. He is the creator of this thing, and this thing is the core of OpenClaw. So just a small side thing. So again, building agents is not the hard part. So what is the hard part when we work with coding agents, or with agents in general? So for the people who are not coders, sorry, but if you're working with ChatGPT or if you're working with Claude, this might still apply. It might open your eyes. So the biggest problem that we have. Question? Yes.
I would say the biggest problem I had with building one was storage. Like the use of RAM and what is that? The one they use.
With RAM or SSDs or like persisting data?
They changed it up, like to save what you said and keep it following your commands.
If you want to learn about, like this guy who built Pi did an amazing job in doing that in a tree-like structure. So if you just launch Pi and you type /tree, you see how he did it, how he saved all his sessions. Really cool idea he had there. Claude Code copied it, and OpenCode copied it as well. Yeah, so biggest problem is state. Because whatever, you heard about this, like garbage in, garbage out, and things like that, right? So what does garbage mean? Like we hear that a lot, garbage. So you have a conversation, is that now garbage? So you were pretty focused. Is that garbage? Yes, it's garbage. Because it's just a conversation you had with the agent with a lot of nonsense in there that no one cares about. The only thing you care about when you're having a conversation with an agent is the outcome. So what you get is some sort of artifact out of a conversation. That state. You want to store that state somehow. If you use tools like Claude Code, like ChatGPT or whatever, it does it for you. You don't know what's happening. So to understand why state is important, let's look at state. So that's state. That's your context window. Who knows what a context window is? Okay, so the context window is the amount of tokens you can send to an LLM the maximum amount of tokens you can send to an LLM. If you exceed that, it will just stop working. And the first thing usually that you put into such a context window is what they call a system prompt. So you instruct it a little bit what it is. What's there, you're a coding agent, or you are a world-class professor in physics, and so forth. So you give it a bit of like a ground layer. So this is your boot sequence of your LLM. If you're using Claude Code, it's more like this. It's a bit bigger. And we see later on why that matters. So then you start a conversation and you send a message. And yes, the agent answers. And you send another message. And because the agent is an agent, he will call a tool, he will use the screwdriver, and so forth and so forth. Your context window fills up, your state fills up. What happens then? Does anyone know what happens when the context window gets full? Yeah, usually. Yeah.
It resets or it stops working.
Yes? Compacting, right. So that's what's happening. So the coding agent right now, that might change in the future, will take all of that, summarize that, create a new session, and throw a compact version of that over. So now you're starting here, right? And you continue your conversation. Now imagine what's in there. Is that an artifact? Is that something that you read and you thought, like, this is good. I want to carry that forward in my conversation? Probably not. Like, I don't even know where to read the compact stuff. But you keep going, and all of a sudden you go, what the fuck? And it comes up with weird stuff, and you will read things like, yeah, you're absolutely right. Has anyone seen, like, yeah, you're absolutely right? Okay. This is where you're in danger. This is what happens when you start compacting and putting more stuff in. You're entering something that Dexter Horthy calls the dump zone, where LLMs get really dumb because they have too much information. Just think about you're standing there, three people talking to you, blah, 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 blah. At some point, you just go like crazy. Okay, so when does this dump zone happen? It happens roughly at 100,000 tokens. That is, from my experience over the last month and multiple other people I spoke with, like there's papers around that, 100,000 tokens. When everything that comes out of the LLM degrades, you get worse quality. This is bad, right? And now you start another session, and you have all these cool like MCPs in your coding agent, right? And then you have all these cool skills, and you have this crazy agents MD or Claude MD. Doesn't work. You have this crazy agents MD that gives you stuff and lets the agent analyze your repository, and then you compact it. And this is where you are. So you start your conversation, and then immediately with the first thing you say, you're in a moment where everything is just shit. And this is what people call an hallucination and whatever, because your agent forgot actually what it wanted to do. So this is what I'm trying to teach people a lot more in bigger companies, is context discipline. So how do you actually engineer your context? How do you do that? Because one thing, at least like that's my assumption, is agents are best when they don't have to think. So what we want to have agents doing is not thinking. They're really good at doing stuff. So if you look at the code that can be spit out by an agent, if you have good specifications, it's amazing. So how does this work? How can we engineer the context or the conversation with an agent? I like to cut this up into two things. Uphill, you have to do a lot of work. And you have to be like very diligent on things to be able to push something like put this ball here, and you want to push this ball up here, so it rolls down, it's just smooth, and just let the agent run, you let it run autonomously and whatever. We've read a lot of things about this in the last month, about Ralph Wiggum loops and whatever. So this is what you're doing. You're starting off, you're like, hey, I have this idea, I want to build this feature, this product, whatever. And you're having a rough conversation. And at some point you're like, okay, I roughed out the first details. So what do I want to do next? Do I wait for compaction? No, you actually save your work. You save it in a plain, ordinary file. And the next time, you launch another session, and you push the ball further. You go into the details. Try to rough out the gaps, things you didn't know. You ask it things like, roast my idea. And you push it further and further. You will, like in my case that happened, you get pushbacks. You look at your file and it's like, this is bullshit. I don't understand anything I'm writing in there because I'm not writing it. So you start opening the file and actually editing it. And you keep doing that and keep doing that until you give up and just like, what the fuck, just send it off and just do it. Or you're actually confident and you read it. And that's pretty much one of the most important things is you have to read that stuff. You have to read whatever the LLM produced. You have to verify everything for yourself and say, okay, this is what I wanted. Once you're there, you can push it downhill. And it goes pretty fast. But it doesn't mean like you can stop here. If you're writing something like an application for yourself or for like just for fun or the prototype or whatever, just let it go. You don't need to read the code. But in this case, you want to read the code if you're building production apps still. And then you push it. So this whole conversational thing is an LLM and you. You're sitting there. The LLM starts with having no idea what you want. And you have no idea what this thing knows. So you're starting, you want to get both into the circle of alignment. So you want to push or pull the LLM into this alignment circle and go in there yourself. And having this conversation, at some point you're like, it gets it. So yes, you want to both go into the circle. And this is something, there is no like hard fact how you can see that, but during a conversation you will find yourself and okay, we're aligned here, and you're getting more detail and detail, and you have to understand when to say no. At the beginning you say yes to a lot of things, and this is where you start pushing back, and the LLM understands, and you create that common knowledge between the two of you. So, how can you best communicate with an agent, with an LLM? Try to make bounded tasks, small things. Keep things small, even in conversations. One conversation at a time. Start a new one when it's necessary, when you see, that's another thing. Let's do something else. You want explicit inputs. You just don't want to tell it like, hey, read the code base. You want to tell it, read that part of the code base. Or read that artifact. That's the other thing. You want to have artifacts. You want to read through them. You want to verify them with your brain and understand what it means. You don't want to have summaries that you don't read. This is garbage in. You want to have short sessions, smaller than 100,000 tokens. So you want to control your context, because it's the most precious thing you have. You want to push out really good stuff. And again, to the artifacts, you want to have these trusted artifacts, and that means you verified them. Maybe you had a coworker, you wanted to verify that with a coworker. That's what I meant. And this is one of my most used commands is clean or new to start a new session. Do that over and over, even if you don't think it makes sense. And don't forget human thinking. So I tried a lot of autonomous runs in the past, and I tried things like, you may have heard of Gastown and things like that. And I found the ultimate slot machines out there. It created amazing stuff that was not possible to carry forward. So the lesson I want to tell you today is, build a coding agent to understand how these things actually work from first principle, control the state, to control the outcome. That was it. And if you want to learn more, on this website, if you want to try out the coding tutorial, just throw it into an LLM and tell it to build it. And then play with it for a couple of minutes. And yeah, x.com if you want to see more things. That's it.